Hello, this is video 6 of a 6-video series on symbolic AI, limits of propositional logic. What about other logics? Now, one thing to remember is that all those definitions and rules we have seen are only one possible definition for a logic that is suitable for a certain purpose. It is a language, much like how notes on a partition are most suited to sharing and communicating music than sharing or communicating cooking recipes. Some constructions of propositional logic also omit the equivalence operator because it can be defined using the implication. Indeed, if you have taken a course in mathematical logic, you might know that A implies B and B implies A is equivalent to A is equivalent to B. In fact, it is possible to only use one special operator and the constants to build any logically equivalent formula you already can with the operators we have used. Of course, this is a bit harder to read, so we have kept the or, the and the not because they are close to natural language and relatively easy to understand. Now, let's discuss a little consideration about that complexity of modeling. Imagine if Gerbert had wanted to describe his position in the city of Rome by writing down the street name and the street number of the building he is at. In propositional logic, he would then use symbols, variables, such as Gerbert at number 3 of street Appia Antica, but if he wanted to describe all his possible positions in Rome, and even with only 10 street numbers and 100 street names, he would already need 1,000 different variables. Furthermore, if he wanted to also describe the position of his brazen head in Rome, he would need 2,000 different variables, such as my brazen head at number 7 of street Via dei Fiori Imperiali. That quickly becomes unmanageable, and proposition logic is not suitable for these purposes. One solution is to use another kind of logic called predicate logic, or first-order logic, that permits the use of function symbols. Function symbols allow you to access properties of the object that you manipulate, such as the position of a variable. Thus, Gerbert can now write a formula such as position Gerbert or position brazen head, which only requires 3 variables instead of the 2,000 in propositional logic. There is a trade-off, however. Even such representative power to our logic makes it much more complicated to solve problems in the general case, so people sometimes use what is called a fragment of first-order logic that is a little bit more powerful than propositional logic, but not so much that it makes automated reasoning impossible. Another modification we can consider for our logics is to change the nature of the interpretation map. So far, we have seen that it will assign to any variable a value true or false. This is quite natural when it comes to describing things that can either be true or false, such as Gerbert sings the Mass or Gerbert dies. But some properties can be much harder to define this way. This is a kind of property onto which we can use the adverb very, as in very evil, very old, very nice, which you can compare with very singing the Mass or very dead. One solution to this is to increase the number of truth values that the interpretation can take. For example, in multi-valued logic, we might decide to interpret variables in a scale from 0 to 5, with 5 corresponding to someone who is very old, for instance, and 0 to someone who is very young or very not old. Fuzzy logic takes it even further in the continuity by assigning real variables, for example, between 0 and 1. Something that is without question old will be interpreted as 0, and something that is without question young will be interpreted as 1. but something has to get a score in the middle, will be both young and old, but at varying degrees. Amongst other things, it allows people to perform more subtle comparisons, here regarding the ages. In systems and controls, it can model the probabilities of failure of a systems and can allow an AI to choose the best behavior given a certain situation. As usual, here are some links and resources to search for you if you feel like learning more about these logics. Let us conclude and wrap up what we have learned during this series. We have learned what symbols are. We have learned what uses symbols are to communicate and to eliminate ambiguities. We have learned what logic is. We have learned what uses logic has. We have used a particular kind of logic called propositional logic. We have learned how to build formulas in propositional logic and how to read them. We had only focused on the syntax, but also considered the notion of truth or interpretation of a formula to relate formulas to the world. Finally, we saw some examples of other logics and the ways of representing truth that are suitable for different problems. I hope this series has given you a taste of symbolic logic in AI and has given you some resources to research it more. And I wish you good luck in your future logical endeavors.